So just a fact, just notice that none of these problems up here talked about being distinct or having no repeats. So that's going to be a little bit different. So let's start with this. So when I want to find out ways to find each of the steps, I would multiply each of them together. So pick one and pick another and pick another, and and in math language is multiply. Okay, so here I have 4 letters. So 4 letters, I'll put them in green, and then 3 digits. So they'll put those in blue. So how many plates possible are there? Well, let's think about it. On the letters, don't I have 26 for each choice? And then for the digits, don't I have 10? Yes, I have 10 choices for each of the digits. All right, so now same idea, 4 letters, 1, 2, 3, 4, and 3 digits. Okay, so now they're saying it has to begin with the letter A. Well, there's only one way to put the letter A in there, that's it. And it has to end in the number 0, so there it is, okay, one way. And then I'd have 26 for each of these other letters, and I'd have 10 for each of these other numbers. Okay, so what about this one? I want TGIF. Well, there's only one way to put TGIF in, so I'm just going to put that be 1. And then I'd have the 3 digits. Okay, distinct, no repeats. So first with the 4 letters, I'd say 26, 25, 24, 23, and then the 3 digits, 10, 9, and 8, and all of those are multiplied. So this is a great way to leave your answer on the test. I'm going to, on your homework, tell you what number that is so that you can kind of compare your answer to see if you got the same number without telling you how I found it, so that you can think a little bit. Then I'll post the solutions and you'll see how I got it. And there can be more than one way. So how many begin with the letter AB? So AB, that's 1, 1. And all others are distinct. So if I can't use A and B, that leaves 24 and 23. And then here I have 3. All others are distinct. I'd have 10, 9, and 8. Okay, so let's go to 4-digit integers. How many 4 digits? So this is counting them, right? So that's just the 999, subtract 1,000, add 1. So there's 9,000 numbers between 1,000 to 9,999. Okay, so here's where it gets trickier. We want odd numbers. Okay, so we always want to pick the hardest thing first, which is going to be the last digit to be odd, right? So I'm just going to make little placeholders. So here's my 4-digit number. So for the number of choices here, it's going to be 1, 3, 5, 7, or 9. So I have 5 choices there. Okay, now let's go to the first digit. So it doesn't say you can't have repeats, so I could have one of those numbers, but I cannot have 0. So I gotta have 9 choices there, and then the other ones I could have any number at all. Okay, so here we go with the distinct digits. So adding a little bit, it doesn't say odd, it just says how many. So that means the first digit is the one that has the most criteria, and that's not 7. I'm sorry, not 0. Not 0, so that's 9 choices. Can't use what I used here for here, so that'd be 9 and 8 and 7. So now I've got all the things, odd, distinct digits. So again, I'm going to go with the 1, 3, 5, 7, 9. So I'll put, there's 5 choices there. Okay, so then what do I have here? I can't have 0, and I can't have the last digit. Whatever I use there, I can't use here, right? So that means I only have 8 choices left. And so for this one here, I've used 2, so that gives me another 8 left, and then there would be 7. Okay, probability. Oh, this is probably going to use what I've been using. Probability of choosing a 4-digit integer with distinct digits from these numbers. Okay, so this uses the number of numbers would be 9,000, right? That's the big denominator of our fraction. Distinct digit, 4-digit numbers, that would be this answer here, right? So 9 times 9 times 8 times 7. And that's a fine answer, just leaving it just like that. Okay, so then here's where it gets a little trickier. So here, when I want even digits, so maybe you're first thinking, la, 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 I know this has got to be a 0, a 2, a 4, a 6, or an 8, right? Oh, 0. It's got that 0 thing. So I think we need to break it up like cases. So I want to, 1, 2, 3, 4. I want to say put 0 here, or put 2, 4, 6, or 8 here. Okay, so if I'm putting 0 here, there's one way to do that. And distinct digits, I already used 0, so I really do have 9 choices left, and then 8, and then 7. Okay, so if I use one of these numbers here, how many choices do I have here? Not 0, and then not the last digit. So I only have 8 choices. And there's 4 choices here, right? Of these numbers, there's 4 choices. And then here, so to get to this digit, I have used 2. So there's 8 and there's 7. So when there's cases, you need to break it up into addition. Okay, so looking at, this is a big range. 1 through 1,000. Let me pause here.